Hello, welcome to the video. In this lesson, we're going to be looking at section 9.1, where we're going to be looking at right triangle trigonometry. The central question here is how can you find trigonometric functions of an acute angle? So anytime that you have a right triangle and you were attempting to discover what the angle is or what the sides are, there are six trigonometric functions. So what we have here are the six trigonometric functions, all right? So the three most common are sine, cosine, and tangent, okay? What it says here is each one of those trig functions is a ratio, all right? And it has different names. It says opposite, it has adjacent, and it has an hypotenuse. So if you were to look at a right triangle, for instance, and you were trying to find the angle theta, because that's what that sine is here, is theta. What we're going to do is this. If you're looking at that angle, the side opposite is your opposite side. The angle that is next to it is called the adjacent side. And the hypotenuse is always going to be the side that is opposite my 90-degree angle. All right. And so that's where we discover what those ratios are with respect to the trig function. Okay. So if you know the opposite and you know the hypotenuse, you're going to use sine. If you know the adjacent, you know the hypotenuse, you're going to use cosine. And if you know opposite and you know adjacent, you're going to use tangent. The other three are reciprocals to sine, cosine, and tangent, respectively. So this one here is um, cosecant. This one here is secant, and this one is cotangent. And if you notice, they're just reciprocals. So this one here is opposite over hypotenuse. This is hypotenuse over opposite, and so on and so forth. Okay. So what they are asking us to do here is they want us to evaluate the six trigonometric functions of the angle theta. So my angle theta is located right here. So what I'm going to do is I'm just going to type in sine theta, cosine theta, tangent theta, and then I'll do my reciprocals, which is cosecant theta, secant theta, and cotangent theta. All right. Looking at the right triangle, the only measurement I don't have is the hypotenuse. Well, I can discover what the hypotenuse is by just implementing the Pythagorean theorem. A squared plus b squared equals c squared. All right. A and b are 5 and 12 respectively. 25 plus 144 is 169. Square root of 169 is 13. So I know what all three side measurements are, so I'm able to discover what those evaluations of those trig functions. So first off, it is opposite over hypotenuse. My opposite side is 12. My hypotenuse is 13. So sine of theta is 12 over 13. Cosine is adjacent over hypotenuse, so that is going to be 5 over 13. Tangent is opposite over um, adjacent, and that is 12 over 5. What you look at for the reciprocals is you just flip what the respective sine, cosine, tangents are for cosecant, secant, and cotangent. This one, um, cosecant is 13 over 12, secant is 13 over 5, and cotangent is 5 over 12. And those are my six evaluated trigonometric functions. Here it says in a right triangle, theta is an acute angle and the sine of theta equals 4 over 7. They're asking you to evaluate the other 5 trig functions. So what I like to do is I like to make my right triangle. I'll pick my side for theta. And here they give us a bit of information where sine is 4 over 7. Well, this, right, if you recall, is the opposite, and this is going to be my hypotenuse. So that means that in this triangle here, 7 is my hypotenuse, and 4 is my opposite right here. So what I don't know is I don't know my adjacent. So again, you use the Pythagorean theorem, a squared plus b squared equals c squared. And in this case, I'm trying to find b. So this is going to be like 16 plus b squared is equal to 49. B squared equals, what, 33. So taking the square root of that, my adjacent is going to be the square root of 33. All right. So to find the other 3, so this is going to be, so I got cosine theta, I got tangent theta, I got, actually I'll work with these two right for right now. So cosine is going to be adjacent over hypotenuse, so square root of 33 over 7. Tangent, it's going to be opposite, so it's going to be 4 over square root of 33. You can't do that because you can't have radicals in the denominator. Um, so rationalize it in this case, so that's going to be 4 times by square root of 33, all divided by 33. So those are the two um, cosine tangents. So if I look at cosecant of theta, that is going to be 7 over 4 because it's flipped from here. Secant is going to be 7 over square root of 33. When you rationalize it, actually going to be 7 times by square root of 33, all divided by 33. And then cotangent is I'm just going to take the reciprocal of this, so it's going to be the square root of 33 over 4. So those are the 5 trig functions from that given information. All right, so like questions 1, 2, and 3 are just like the previous examples. Uh, and also question 4 is just like the one we just looked at. If you are, if you need additional help or you're like, I'm just not sure what to do, please leave me a comment down below. I'm more than happy to work out these problems then. Here we have what is called trigonometric values for special angles. So anytime you have something that is a 30-degree, 45-degree, or a 60-degree, there are special angles that result in the sine, cosine, tangent, cosecant, secant, and cotangent. Um, it helps to memorize these, but having this chart here is helpful um, in order to evaluate these types of functions. But so here they are. So like the sine of theta, so basically the sine of 30 degrees is 1/2. Cosine of 30 degrees is square root of 3 over 2. Tangent of 30 degrees is square root of 3 over 3, so on and so forth. And we have all the rest of them as well. So here they want you to find the value of x for this right triangle. All right, so in this case we have 30 degrees. 30 degrees with respect to x is adjacent, and we have the hypotenuse, so that means we are going to be dealing with cosine. So I have the cosine of 30 degrees is going to be equal to adjacent over hypotenuse, so x over 8. Well, if you look back at your chart, the cosine of 30 degrees is the square root of 3 over 2. So now I got the square root of 3 over 2 equals x over 8. To solve for x, multiply 8 to both sides. So that means that I get 4 times by a square root of 3 equals x. Here with 5, it's 45. We got adjacent, we got an hypotenuse. In this case, this is the cosine of 45 degrees equals x over 6. Cosine of 45 is square root of 2 over 2. That equals x over 6 times 6 to both sides. So x is going to be equal to 3 times by square root of 2. Here with questions 6, 7, 8, and 9, uh, you're going to use this diagram here to help you out. So they're giving you some of the values, and in this case, you're going to be asked to find uh, the unknowns. So, for instance, like if I looked at question 8, they're telling you that A is 71 degrees. So this is 71 degrees, and they're telling you that C is 20. So in order to discover what this is, what you're going to do is say like, all right, let's say I'm trying to find A. So with respect to 71 degrees is that's opposite, you know, hypotenuse. So that means you're going to take the sine of 71, and that is going to be equal to A over 20. Well, now to get A, you're going to multiply 20 to both sides. Now I get 20 times the sine of 71. So what you need to do when you look at your calculator, you'll see sine, cosine, and tangent on your calculator. Make sure if you like go to like a mode, make sure that your uh, setting is in degrees and not radians. So when I take the sine of 71 degrees and I multiply it by 20, I get a value of about 18.91 for A. Now for B, it is, with respect to 71 degrees, it's adjacent over hypotenuse, so it's going to be cosine of 71 degrees is going to be equal to B over 20. So now you multiply 20 over here, and now I got cosine of 71 times that by 20. Whoops. And I get B's to be equal to about 6.51. So that is how you find those. And again, if you have additional questions on 6, 7, or 9, let me know. But that's uh, how we kind of solve those, especially when uh, your angle measure is not one of those special ones. So like 71 degrees and like the 32, you're gonna get decimal values for your side measurements. With like 60 and 45, those are special angles, so you're gonna get more exact measurements because you're gonna use the chart to help you solve them. Here it says you are hiking near a canyon while standing at A. So here's you're standing at A. It says you measure an angle of 90 degrees between B and C as shown. When you walk to B and measure an angle of 76 degrees between A and C, the distance between A and B is about 2 miles. How wide is the canyon between A and C? So they're trying to find X. So it's a little hard to see here. So X is right there. So in this particular instance, since you know it's 76, this is opposite and 2 is adjacent. So that means we are going to be using tangent. So the tangent of 76 degrees is going to be equal to opposite, which is x, over adjacent, which is 2, times 2 to both sides to find x. And now I get tangent of 76 times it by 2. I get something really close to about 8 miles. And that is being able to look at right triangle trigonometry. Hope this helps. Till next time.